Hey guys, welcome back to Maths Cube. Today I'm solving the second question that's from International Advanced Level Mechanics M1. So without further ado, let's get started. The second question is two particles P and Q have masses 2m and m respectively. The particles are moving towards each other in opposite direction along the straight line on a smooth horizontal plane. The particles collide directly. Immediately before the collision, the speed of P is 3u and the speed of Q is 2u. The magnitude of impulse exerted on Q by P in the collision is 5 mu. Find A part, which is the speed of P immediately after the collision. So guys, always in the momentum questions, draw the graph and label the points they have been given. There you go. That's my P particle and Q. And it says that the P particle has a mass of 2m. So I'll write it here. And the Q particle has a mass of m. Moving on the speeds, they are moving towards each other. So it's very important to draw the direction in momentums. Question, there you go. The P and Q are moving towards each other. And they say that immediately before the collision, the speed of P is 3u. So I'll write 3u here, and the speed of Q is 2u. So these are the initial speeds. There you go. And they say that find the speed of P immediately after the collision. And before that, they also have given the one piece of information, that is the magnitude of impulse exerted on Q by P in the collision is 5 mu. So where does that go? So the direction of impulse will go on the opposite side, in that side, and to the other side of P. So you can mention it 5 mu. That's our impulse. Both have been experiencing the impulse. There you go, 5 mu. And now to the main part, the speed of P after the collision, which means they're asking us the final speed of P. If you remember the impulse equation, which is impulse is equal to change in momentum, you can say, which is mv minus mu. And we know we are finding for the P only, so m will be the same, that you can take out as a factor, and that's v minus u. So this is how it goes. Now what I'll do is I'll just plug in the values. Here you go, 5 mu equal to 2m, and the bracket is v minus 3u. Now I'll expand the bracket. One thing I forgot to mention is the impulse on P is on the opposite side, which is here, you can see. So don't forget to add the minus sign. So that's important. Always remember the signs and the negative and the positive ones and where to add them and their direction. So when I expand this bracket, I get minus 5 mu equal to 2 mv minus 6 mu. We'll cancel the like terms, which is m here. That's been repeating a lot. So I'll just remove it, and we'll be left with minus 5u equal to 2v minus 6u. Now take all the 6u, or the like terms, which is 6u, the u term, to that side. So it will become positive to make v the subject. Here you go, minus 5u plus 6u equal to 2v. Now just doing basic maths, we are left with a positive u or 1u equal to 2v. Now to make v the subject, what I'll do is I'll divide 2 from both sides. So I'll end up having, now that we are done with the A part, moving on to the B part, we have to find the speed of Q immediately after the collision. Now coming at the final speed of Q. So guys, again, as I said, use the same impulse equation to find the Q value as you did to for the P value. There you go, that's the impulse formula we will be using. I equal to m into v minus u. Plugging in the value, there you go, 5 mu equal to m into v minus 2u. Now the reason I'm using minus 2u is because of the direction. You can see the 2u is in the opposite direction of P. And remember, I'm using a positive impulse because it is in the positive direction. You can see it's in the right direction. So now expanding the brackets, there you go, 5 mu equal to mv plus 2 mu. Again cancelling the like terms, which is m being repeated a lot of times here. And now we are left with 5 equal to, or 5u equal to v plus 2u. Now what I'll do is I'll just subtract 2u from both sides to get v as our subject. Doing some basic maths here. So our v value or the speed of q immediately after the collision is 3u. So that's our final answer. 3 marks from A part and 3 marks from B part is 6 marks. So 6 marks for this momentum question. Thanks for watching, guys. If you like the video and the method, do subscribe and stay tuned for more videos from this series.